Download this code from codegive.com, link in the description below. Call by value versus call by reference in C, a deep dive. In C, function arguments are passed in two primary ways, call by value and call by reference. Understanding the difference between these mechanisms is crucial for writing correct, efficient, and predictable code. This tutorial will cover both approaches in detail, illustrating their behavior with code examples and highlighting their respective advantages and disadvantages. 1. Call by value. Definition call by value means that when you pass a variable to a function, a copy of the variable's value is created and passed to the function's formal parameter. The function then operates on this copy, not the original variable itself. Any modifications made to the parameter within the function do not affect the original variable in the calling code. Mechanism 1. The value of the actual argument, the variable you're passing, is copied. 2. This copy is assigned to the formal parameter of the function, the variable declared in the function's parameter list. 3. The function executes using the copy. 4. When the function finishes, the copy is discarded. The original variable remains unchanged. Code example output explanation One number is initialized to 5 in main. 2. When increment, number, is called, a copy of the value of number, which is 5, is passed to the increment function and assigned to the formal parameter x. 3. Inside the increment function, x is incremented to 6. The printf statement confirms this. 4. When increment returns, x is discarded. The original number in main remains unchanged at 5. The final printf confirms this. Advantages data protection the original variable is protected from accidental modification within the function. This enhances code reliability. Simplicity it's generally easier to reason about the behavior of functions when dealing with call by value because you know that the original variables will not be affected. Disadvantages inefficiency. For large data structures, copying large data structures, like large arrays or structures, can be inefficient in terms of memory and processing time. Cannot modify original variable directly. If the goal is to directly modify the variable passed to the function, call by value is not appropriate. 2. Call by reference. Definition call by reference, which is simulated in C using pointers, means that you pass the memory address of the variable to the function. The function then accesses and manipulates the original variable directly through this address. Any changes made to the parameter within the function do affect the original variable in the calling code. Mechanism, using pointers. 1. The address of the actual argument is obtained. 2. This address is passed to the function's formal parameter, which is declared as a pointer. 3. The function uses the pointer to dereference, access the value at, the memory location of the original variable. 4. Modifications made through the pointer directly alter the value of the original variable. Code example output explanation One number is initialized to 5 in main. 2. When increment, and number, is called, the address of number, not the value 5, is passed to the increment function. 3. The formal parameter x is a pointer that now holds the address of number. 4. Inside the increment function, x dereferences the pointer x. This means it accesses the value stored at the address that x points to, which is the address of number. 5 x equals x plus 1, increments the value at the address pointed to by x, which directly modifies the value of number in main, to 6. 6. The printf statements confirm the change within the function and after returning to main. Asterisk advantages asterisk. Asterisk modify original variable asterisk allows functions to directly modify the values of variables in the calling code. Asterisk efficiency, for large data structures passing an address, a pointer, is much faster and more memory efficient than copying large data structures. Asterisk returning multiple values asterisk although C does not natively support returning multiple values from a function, you can effectively achieve this by modifying multiple variables passed by reference. Asterisk disadvantages asterisk. Asterisk potential for unintentional modification asterisk since the function can directly modify the original variable, there is a risk of accidental modification if the function is not written carefully. This can lead to unexpected bugs. Asterisk complexity asterisk working with pointers adds a layer of complexity to the code, which can make it harder to read and understand, especially for beginners. Asterisk dangling pointers asterisk if the memory pointed to by the pointer is deallocated or becomes invalid, using the pointer can lead to a crash or undefined behavior. 3. When to use which? Here's a general guideline for choosing between call by value and call by reference. Asterisk call by value asterisk. Asterisk when you don't need to modify the original variable. Asterisk when you want to protect the original variable from accidental modification. Asterisk for small, simple data types, example int, float, char. Asterisk call by reference, using pointers. Asterisk when you need to modify the original variable. Asterisk when you need to return multiple values from a function. Asterisk when you're working with large data structures, example large arrays, structures, to avoid the overhead of copying. 4. Call by value with pointers, important distinction. It's important to understand that you can use call by value even when dealing with pointers. This might sound confusing, but it's a common technique. Asterisk output, likely crashing. Asterisk explanation asterisk. 1. My_PTR is a pointer initialized to null. 2. Modify pointer, my_PTR, passes the value of my_PTR, which is null, by value. This means a copy of my_PTR is created for the PTR parameter within modify_pointer. 3. Inside modify_pointer, malloc allocates new memory, and the copy of PTR is assigned to point to this newly allocated memory. The value 100 is then stored at that new memory location. 4. Crucially, the original my_PTR in main remains null. The function did not modify the original pointer. It only modified its local copy. 5. When modify_pointer returns, the local copy PTR is discarded. The memory allocated by malloc inside the function is now leaked because there is no pointer pointing to it in main. 6. The attempt to printf, value pointed to by my_PTR, %d\n, *my_PTR, causes a segmentation fault because my_PTR is still null, and dereferencing a null pointer is illegal. Key takeaway * in this example, the pointer itself was passed by value. The function modified the copy of the pointer, not the original. If you want to change the pointer itself, i.e., the address it holds, in the calling function, you need to pass a pointer to a pointer, int x. 5. Correcting the pointer example, passing a pointer to a pointer. To correctly modify the pointer itself within a function, you must pass a pointer to a pointer. Output explanation 1. We pass the address of my_PTR using and my_PTR. The formal parameter ptr is now a pointer to a pointer, int ptr. 2 ptr differentiates the first level of pointer, giving you the pointer my_ptr itself. 3 ptr equals, int, malloc, size of, int, assigns the new memory address returned by malloc to *ptr. This directly modifies my_ptr in main. 4 ptr differentiates both levels of pointers, first getting the pointer, then getting the integer value it points to. Ptr equals 100, sets the value at the allocated memory location to 100. 5 after modify_pointer returns, my_ptr in main, now points to the newly allocated memory. We can successfully access and print the value stored there using *my_ptr. 6 free, my_ptr, is essential to prevent a memory leak. 6. Call by value versus call by reference analogy. Think of it this way. Call by value you give a friend a photocopy of a document. They can write all over the photocopy, but the original document remains unchanged. Call by reference you give a friend your original document, or, more accurately, you tell them where your original document is located. If they write on it, they are changing your original document directly. In summary, understanding call by value and call by reference, simulated with pointers in C, is fundamental to writing correct and efficient C code. Choose the appropriate method based on whether you need to modify the original variable and on the size of the data you are passing to the function. Be particularly cautious when working with pointers, as they provide direct access to memory and can introduce subtle bugs if used incorrectly. Always remember to deallocate memory with free, when you allocate it with malloc, or calloc, to prevent memory leaks.